Hello and welcome to the video. We continue our look at the 9618 variant 2.1 pseudocode implementations. So we are looking at this the May-June 2024 variant 2.1 for the 9618 course. And number 6, that's the next question. So it says here that 3 points on a grid form a triangle with sides of length A, B, C, as shown in the example right there. So this is the example of the triangle. Then a triangle is said to be right angled if the following test is true, right? If A, that is the longest side, is equal to the square of the other two sides, is equal to the sum of the square of the other two sides, rather. So they go on to explain with an example right here, right? So immediately you should be able to identify that this is the Pythagorean theorem in action. That's what they're talking about here. So I'm not really going to read everything here because they're just referring to the Pythagorean theorem just in case you might have forgotten. So we are to write a function called this RA, which will take 3 sets of integers as parameters representing the coordinates of the 3 endpoints that form a triangle. Then it's going to return true if the endpoints form a right-angled triangle, otherwise they're going to return false. Then of course they're talking about the caret symbol and its use in pseudocode, right? It means exponents in pseudocode. Like for instance, if you wanted to square a particular value, you just make use of value caret, then the power that you want to raise it to. So in this case, they are raising it to the power of 2. So we've been given a function header, rather a function header and footer, and we're supposed to put the body of the function as it were. So let's go ahead and look at the implementation that I have going on here. So you see that the function header matches the one that you're already given, as well as the function footer. So you won't get marks for that. But what you're going to get marks for is completing the body of the function. So on line 3, that's when we actually have the actual statement. Line 2 is just a comment. We are declaring 3 sides of our right-angled triangle. So if you remember, the Pythagorean theorem states that for a right-angled triangle, the longest side is going to be called the hypotenuse. Then the side at the base is called the adjacent, and the side on the slanting side, rather, is going to be called the opposite. So essentially what we simply need to do is we need to use this logic that they gave us right here, is it? So hypotenuse is going to hold the square of x1 minus x2 squared plus y1 minus y2 squared. And we're also going to do the same for opposite, and we're also going to do the same for the adjacent. Then let me quickly point out that for the lengths that we have going on here, depending on the parameters given, it's not always going to be the case that x1 and x2 will be the hypotenuse, is it? So it also means the same for opposite and adjacent, right? x1 and x3, x2 and x3, they may actually be the opposite of each other, right? Like for instance, this could have been the adjacent, this could have been the opposite, this could have been the hypotenuse, as it were. So the reason why I chose these names is because they are descriptive of what we are trying to implement. Since this program is implementing the Pythagorean theorem, that's why I chose these names right here. So in order to cater for that, in our if statement right here, you see that we are testing 3 conditions, is it? Because we are not really sure which one is the hypotenuse, right? So we have to test, we have to cater for all this, for all these 3 situations whereby the opposite could have been the longest side, or the adjacent would have been the longest side, is it? So the way we are doing that is to make use of an OR operator, right? And if you remember how an OR operator works, is that it's going to return a true if any one of these 3 conditions is true, is it? But let me quickly point out that I'm using a different kind of approach right here. So ordinarily what you would have done was to check to see if these 3 conditions, right, then you return true, then you would have an else clause right there, then you would return false. But you see that I'm using this approach where I first check to see if not, right, simply saying that if any of these conditions is not satisfied, right, I want to return a false. Otherwise, I will simply return a true. So this technique that I'm using right here in programming, it's called the fail fast approach. So essentially, we want our logic to fail the moment we don't satisfy any conditions. We simply want to return a false. So this approach, in terms of performance, it wouldn't be different from having an else clause here with a return false and having removed these brackets and this not statement and putting return true, is it? There's no difference in terms of performance, but in terms of code readability as well as code maintenance, the fail fast approach is recommended, because it's more efficient in maintaining the code, as it were. It's also called the early return method. It's also called the early return technique rather. So we are checking to see if any of these conditions is not satisfied, then return false, right? Remember this that our function returns a boolean true or false, depending on the situation. So in this case, it means that the triangle is not right angled is not a right angled triangle. Otherwise, we are simply going to return a true. Then take notice of the position where this return true is it? It's not out inside of the if statement, but it's outside of the if statement. So should this condition not be should not be met, it's going to return false. Otherwise, if the condition is met, it will return true. So the fail fast approach, or the early return technique, allows us to quickly return a result, as it were, and it's also going to make our code easy to read. And yeah, I think that's just about it for this episode. I'll see you in the next one.